Assuming we kill the lines, the most spellbinding star I acknowledge is the one that could be stunning in our sky. It is called Betelgeuse or Scarab Crush, a red giant star. On the slim chance that you put it where the sun is, it would stretch to the orbit of Jupiter. It's monstrous, extremely whimsical, and destined to explode. However, things in the universe are not always as they seem. These legendary events, like the most dreaded massive starbursts, could severely affect all that we see and don't see. Betelgeuse has been viewed as a sign, a red giant star several times more massive than our sun. Experts like Brian Cox and other astronomers believe it could go supernova at any moment. People are naturally concerned, especially since the James Webb Space Telescope has been taking astonishing photos of the star. So, when exactly will Betelgeuse, become a supernova, and how enormous will its impact be on Earth? Let us explore this star, located in the constellation Orion, which shines so brightly that even ancient civilizations noticed it. The famous star Betelgeuse is situated on the eastern shoulder of the constellation and is the second largest star in the formation. Its name derives from this feature, the beast's shoulder. It is perhaps one of the brightest stars in the night sky. In addition to being unusually bright, the star has an odd red hue, which, as we will see, indicates trouble. We've known about Betelgeuse for centuries. A Greek analyst named Tmy also studied it long ago. Around that time, people first noticed the star's color, which Tmy described as orange. More recently, scientists have been studying the star closely and now have a better understanding of what makes it so extraordinarily bright. One of its key features is its variability in brightness. With an apparent magnitude of 0.6, Betelgeuse is a variable star, meaning its brightness changes over time. However, in 2019, scientists observed something unusual. Betelgeuse's brightness diminished significantly, glowing at a level of about 1.6. This dimming puzzled researchers, as the star had previously been one of the 10 brightest in the sky. Experts have since uncovered alarming findings, including signals suggesting that Betelgeuse could go supernova at any time. Renowned physicist Brian Cox, a professor of particle physics at the University of Manchester, made headlines with this claim. Cox emphasized that Betelgeuse resembles a ticking time bomb that could explode without warning. The situation became even more compelling when the James Webb Space Telescope provided evidence supporting this claim. But what exactly are the unusual signs from Betelgeuse that are causing so much concern? Betelgeuse is classified as a supernova candidate, primarily due to its immense mass, several times that of the Sun. For a star to go supernova, it must exceed a certain threshold of mass. Using advanced instruments like the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, LIGO, scientists have gathered intriguing data about the star and its surroundings. Betelgeuse's story dates back approximately 10 million years. Recently, however, the star has exhibited strange behavior, including peculiar light waves and irregular dimming. This variability is characteristic of dying stars. Betelgeuse's dimming cycle, for instance, has become faster and more pronounced. In February 2021, researchers noted an unusually low brightness level of 1.61, shortly after the famous Great Dimming of 2019. During the Great Dimming, Betelgeuse's brightness dropped dramatically, causing widespread speculation that the star might soon explode. Between 2019 and 2020, the dimming magnitude reached a record low of 1.2, further fueling concerns. Interestingly, Betelgeuse rebounded after the Great Dimming, becoming 150% brighter than usual. Today, it is the seventh brightest star in the sky. Astrophysicist Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics noted that Betelgeuse's recent brightness is unprecedented. So, what caused the Great Dimming? Scientists suspect that a massive surface mass ejection, SME, played a role. New data from the James Webb Space Telescope reveals that this SME was approximately 400 billion times larger than a typical coronal mass ejection from our Sun. The telescope also detected strange dust clouds near the star, which further complicates the mystery. Despite its instability, Betelgeuse is expected to shine for several more decades. However, given its unpredictable behavior, some researchers remain cautious. If Betelgeuse explodes, it would mark the first supernova observed by humans since Johannes Kepler witnessed one in 1604. Although scientists are confident that Betelgeuse will eventually go supernova, the exact timing remains uncertain. For now, they continue to monitor the star using the most advanced tools available, hoping to unlock the secrets of this enigmatic giant. Betelgeuse's potential supernova event has captivated scientists and the public alike. A supernova explosion of this magnitude would release an immense amount of energy, briefly outshining an entire galaxy. The aftermath would leave behind a neutron star or possibly even a black hole, depending on the remaining core's mass. If Betelgeuse were to explode, the light would be visible from Earth even during the daytime. It could shine as brightly as the full moon, casting eerie shadows and dominating the night sky for weeks or months. However, researchers are keen to emphasize that the star is far enough from Earth, about 642.5 light-years away, that the explosion would not pose a direct threat to our planet. That said, the effects of a Betelgeuse supernova on our cosmic neighborhood would still be profound. The explosion would release a flood of high-energy particles and radiation, which could impact nearby interstellar material. This might create shockwaves that compress surrounding gas clouds, potentially triggering the formation of new stars. However, there is much we still don't understand about the timeline of such an event. Stars like Betelgeuse spend millions of years in the red supergiant phase, and their transitions into supernovae are not precisely predictable. While some experts believe it could happen in the next 100,000 years, others think it might occur much sooner, or much later. Adding to the intrigue is Betelgeuse's role as a key subject in ongoing astronomical research. The James Webb Space Telescope, with its unparalleled infrared capabilities, continues to monitor the star closely, searching for signs of further mass ejections or other peculiar activity. Meanwhile, ground-based observatories and instruments like LIGO are ready to detect gravitational waves, a potential signature of a star's final collapse into a supernova. For now, Betelgeuse remains an enigmatic giant, serving as a reminder of the universe's grandeur and unpredictability. Whether it explodes tomorrow or in 10,000 years, the star offers scientists a unique opportunity to study the life cycle of massive stars. Its eventual supernova will be a historic event, both scientifically and culturally, marking the end of one chapter for the star and the beginning of new cosmic phenomena. Until then, Betelgeuse continues to shimmer in the constellation Orion, inviting stargazers and scientists alike to marvel at its brilliance and mystery. Its unpredictable nature serves as a testament to the ever-evolving and dynamic universe, a universe where even the most massive and enduring objects eventually meet their spectacular end. A prime contender for an impending cosmic explosion, Betelgeuse has researchers profoundly concerned due to its gigantic size and increasingly peculiar behavior. For example, the extraordinary dimming event in 2019 raised significant alarm, marking an abrupt and radical decrease in brightness, something never seen in such a prominent star before. Initially, specialists struggled to understand the cause of this dimming, as it was highly unexpected for such a stable and well-known celestial body. Some hypothesized that this could be a sign that Betelgeuse was on the brink of exploding into a supernova. Others considered alternative explanations, suggesting the dimming might have resulted from phenomena within the star itself, such as an enormous cloud of gas and dust blocking its light or an internal structural adjustment causing it to temporarily lose luminosity. Following this dimming event, the star's sudden increase in brightness over the subsequent months only deepened the mystery. Betelgeuse's drastic fluctuations in brightness suggest it might be undergoing a volatile phase in its life. It may be experiencing what is known as a pulsation phase, where its outer layers expand and contract in cycles, releasing bursts of energy. While this behavior is typical for red supergiants, Betelgeuse's rapid variations are unlike anything observed in other stars of its size and type. The cause of these anomalies remains unclear, but they have drawn significant attention to the star. In addition to these unusual light patterns, astronomers have detected unexpected features on Betelgeuse's surface, such as the aforementioned dust clouds that resemble leaves in space. These structures hint at a complex, turbulent environment surrounding the star. The proximity of these clouds to Betelgeuse's outer layers is alarming. These clouds might have formed from ejections of gas due to internal instability, or could be the result of the star shedding its outer envelope in preparation for a catastrophic transformation. Such mass ejections could signal an impending supernova, although it's unclear if Betelgeuse is losing enough material to trigger such an event. Another critical factor in the ongoing study of Betelgeuse is its mass. As previously mentioned, Betelgeuse is several times more massive than the Sun, placing it firmly in the category of stars destined to end their lives with a supernova. Stars of this size typically undergo dramatic stages in their final years, experiencing massive internal shifts before their cores collapse and trigger a colossal explosion. Given its size and the current instability being observed, it is believed that Betelgeuse could explode within the next 100,000 years. However, as is often the case with cosmic events, this could happen much sooner, or much later, than anticipated. The precision of this estimate remains a topic of debate within the scientific community. The possibility that Betelgeuse is in the final stages of its life has raised many questions about what the aftermath of its death could look like. If it does indeed go supernova, it would be one of the most significant cosmic events witnessed within the span of human observation. A supernova explosion can release energy equivalent to the Sun's output over its entire lifespan and can briefly outshine an entire galaxy. If Betelgeuse were to go supernova, it would be visible to the naked eye, even in the daytime, and could be observed from Earth for weeks or months. Such an event would undoubtedly captivate astronomers and stargazers alike, but it could also have more serious implications for our planet. Despite its extreme distance from Earth, about 640 light-years, a supernova of Betelgeuse's magnitude could still affect our planet. While the explosion wouldn't be close enough to cause significant physical damage, the radiation it emits could pose a threat to Earth's atmosphere. If the blast produces large amounts of high-energy gamma rays or X-rays, it could potentially damage the ozone layer, leading to a temporary increase in ultraviolet radiation reaching Earth's surface. This could have harmful effects on life, particularly on plant and animal species that rely on the ozone layer for protection. In addition to potential atmospheric changes, scientists have speculated that a supernova of this scale could disrupt the solar system's dynamic balance. The shock wave from the explosion might disturb the interstellar medium, potentially affecting the orbits of comets and asteroids. Though this might sound like science fiction, the gravitational and electromagnetic waves generated by a supernova can have far-reaching effects on the surrounding cosmic environment. A nearby supernova could trigger a cascade of events that ripple through the solar system, altering the trajectories of objects within it. On a more speculative note, Betelgeuse's potential explosion could provide insights into some of the most fundamental questions of physics. Supernovae are believed to be key laboratories for studying the nature of matter and energy under extreme conditions. The death of a star like Betelgeuse could reveal more about the forces that govern the universe, such as the behavior of matter at incredibly high densities, the role of neutrinos in energy transfer, and the processes that lead to the formation of black holes. As scientists continue to monitor Betelgeuse, their understanding of stellar evolution, supernova mechanics, and cosmic phenomena is expanding. Observations made by advanced telescopes like the James Webb Space Telescope are crucial for refining our models of stellar life cycles and preparing us for what might come next. Betelgeuse's relative proximity to Earth, in cosmic terms, makes it an ideal subject for study. Its behavior will likely provide key insights into its eventual demise and the broader processes at play in the universe. Whether Betelgeuse will explode soon remains uncertain. The star's behavior is undoubtedly peculiar, and while it may be in the final stages of its life, predicting when or how a supernova will occur is far from an exact science. As more data becomes available, astronomers will continue to refine their models and predictions. For now, Betelgeuse remains a captivating and enigmatic object in the night sky, one that may ultimately help us understand the explosive forces shaping the universe around us.